Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 19, Atoms, Molecules, and Ions, Part 6. This is the last video in Chapter 2 of your textbook. Here are our objectives for today's video. Pause here. So we've talked a lot about type 1 and type 2 binary compounds. Those are our ionic compounds. And now we're going to talk about type 3, which are our binary covalent compounds. So there are other covalent compounds that are not type 3, but that's not what this video is about. So they're going to contain two types of nonmetals, and they will be covalently bonded. Pause here. So when we name type 3 compounds, so some examples would be like dihydrogen monoxide. You name the first element first using the full element name. So let's say dihydrogen. I'm not changing any sort of suffix. The second element is named as if it's an anion, so you change the suffix to IDE. So oxide. Then we're going to use prefixes. I'm going to put those on the next slide in case you don't already know them. But if we don't use the prefix mono just for the first element, but you will for the second. So dihydrogen monoxide. But if instead of H2O, it was written as OH2, it would be oxygen dihydride. I wouldn't use mono for the first one. Pause here. These just need to be memorized. It's not typically an issue for students in my experience, but up to 10, sometimes you will see it go up that high. Pause here. So there's no crisscrossing, there's no checking the charges on the periodic table because those charges only typically apply when we're dealing with ionic bonding. So this is phosphorus pentachloride. Don't need any mono in the first one. I have dinitrogen trioxide, carbon dioxide. I'm sure you've heard of that. And we don't simplify these either. So dioxygen difluoride. Pause here. All right, so acids, they are not type 1, they are not type 2, they are not type 3. And that's because they're sort of that gray area between covalent and ionic. So acids are covalently bonded until you put them in water. Once they react with water, they become ionic. To name an acid, there are three main types of acids. The first is for things that do not contain oxygen. So this is where we'll get our hydrochloric acid, hydrofluoric acid, et cetera, et cetera. So anytime it does not contain oxygen, it will have hydro whatever-ic acid. If it does contain oxygen, meaning it's going to be coming from the polyatomic ion, because H2O is neutral if you didn't remember that from biology. I go to the polyatomic ion sheet, I find what the anion is, and then depending on the suffix of the anion, that is how I'm going to change the name. So anything that ends with ATE becomes ic. So for example, sulfuric acid, acetic acid. And anything that ends with ITE becomes us, so nitrous acid, perchlorous acid, etc. Okay, let's take a look at an example. Pause here. So the first one, HI, this does not contain oxygen. So this is hydro, and then it's iodine, so iodic acid. The next one, I go to my polyatomic ion sheet. I see that NO3 with a minus charge, that this is nitrate. So this is nitric acid. The next one, I've got HCN. This doesn't contain oxygen. So this is the first type. So this is hydro. CN is cyanide, so hydrocyanic acid. HClO3. So I go to my polyatomic ion sheet. I see that there's something called ClO3, and that is chlorate. So that ends with ATE. So I'm going to change it to IC. So this will become chloric acid. Now I have HClO4. I go to my polyatomic ion sheet. I find that ClO4 minus is perchlorate. So again, we have ATE, so I'm changing it to IC, so perchlorate. chloric acid. And then the last one, I've got H2SO4. I go to my polyatomic ion sheet. I find SO4 with a 2- charge, which is sulfate. So again, ATE, very, very common. We'll change this to sulfuric acid. That is all for today's video. Thank you so much for watching and have a great night.